Today we are doing the Is Yeast Alive lab. It says humans use yeast every day. What is yeast and what are some common uses of yeast? Well, yeast is a tiny little microorganism. It's a single-celled fungus. So you can buy yeast to make bread in the grocery store. This yeast consists of little brown grains. There's some right here in this one. You can see there's tiny little grains in there. That's yeast. Do you think these little brown grains of yeast are alive? Why or why not? You put what you think there. To find out whether yeast is alive, we first need to think about what makes something alive. What are some characteristics of living things? Well, back the first week of school, we talked about some characteristics of living things. They're going to reproduce. They're going to take in food and give out waste. They're going to grow and develop, and they're going to adjust in their environment. They're going to reproduce. They're going to metabolize. So we're going to look and see if yeast metabolizes today. So to begin to answer the question, is yeast alive? You will test whether the grains of yeast have one of the characteristics of living things, the ability to use energy, which is referred to as metabolism. So what we're going to do is we're going to take our little yeasties here. And so we'll carry out an indirect test for metabolism. In other words, we will be indirectly testing whether yeast can use energy, which is one of the characteristics of living organisms. When yeast, humans, and other living organisms use energy, they break down high-energy molecules like sugars to get the energy they need and to give off a gas called carbon dioxide as a byproduct of this reaction. We will test whether yeast can metabolize sugar and produce a gas, which we will presume is carbon dioxide. Specifically, we will test whether yeast produces a gas when it has sugar available as a food versus when no sugar is available. Okay, so our question is, does yeast metabolize sugar to produce gas? Make your predictions. And then we've got our setup here. We'll do that setup. And we're going to fill in this table as we make our observations. This is bottle 1. In bottle 1, I have sugar and yeast. And in bottle 2, I have just the yeast with no sugar. I'm going to add water to each bottle. Water. And I'm going to seal each off with a balloon. Green balloons going on bottle 1 here. The balloons going on bottle 2. And shake them and put my fingers over the top, shake them up a bit. Step off the bottom. And then observations at 0 minutes. At 0 minutes, we have bottle 1's balloon is flat, no air. Bottle 2 balloon is flat with no air. That is our 0 minute observation. And I'm going to pause, and I'm going to come back in 5 minutes, and we'll do our 5 minute observation. Okay, we are back for our 5 minute observation. Balloon 1 with the yeast and sugar. Maybe a tiny bit of air in there. Balloon 2 with no sugar. Maybe just a tiny little bit in there, which could also be steam from the warm water. They both have just a tiny little bit of air in there. I'm going to pause now and go ahead and record your observation for 5 minutes, and I will be back at 10 minutes to observe again. Okay, we are back for our 10-minute observation. Balloon number 1 definitely has some air in it this time. It's starting to get a little puffy. balloon number 2 is still pretty flat. So observation, we have a little bit of air, a little bit of gas, I should say, a little bit of gas in balloon number 1, and balloon number 2 is still quite flat. So record your observation for 10 minutes, and I will be back on in 5 minutes to do our 15-minute observation. Okay, we are back now to make our 15-minute observations. Big change this time. Okay. Balloon number 1 with our yeast and sugar. It's got air in it enough that it's standing up now. So number 1 standing up. Number 2 still floppy with minimal, if any, air in it. So make your observations. Record those for 15 minutes. And then I'll be back in 5 more minutes to do our 20-minute observation. Okay, we're here now to make our 20-minute observation. Again, balloon bottle number 1 maybe a little bit bigger. It's tight. There's definitely some gas in there. And balloon 2 is still flat. Not much going on over here. So go ahead and make those observations. Record them for 20 minutes. I'll be back in 5 minutes to make our 25-minute and final observation. Okay, we're back now to make our 25-minute, our final observations. Okay. Bottle number 2, balloon's tight, definitely has some gas in there. Okay. Balloon number 1, I'm sorry, this is balloon number 1 with the yeast and the sugar. It is tight, it definitely has gas in there. And the balloon number 2, that was just the yeast, no sugar, no gas in there, it's still just a floppy balloon. So there, make your final observations for 25 minutes. Bottle 1 with the sugar has gas in the balloon. Bottle 2 without the sugar has no gas. So go ahead and record those observations. And we'll look real quick at the questions. Okay, number 7 says, discuss the results you obtained with your group. Now, since we are virtual, if y'all want to talk amongst yourselves in the meet, you can do that. If you want to try this at home, it says compare your results. So I don't know if you can compare with the ones doing it in the classroom, or if you want to try it at home yourself and see what you get. And it's up to you. You can try that. If not, we'll just skip 7 then. Some things that might change results might be the balloons. If you have a smaller balloon or a tighter balloon, or if you made some error in the setup or something like that, that could change your results. Okay, 8 says, why is it better to have 1 bottle with yeast, sugar, and a bottle and water, and 1 bottle with just the yeast and the water? Well, this one's our control. We can see what happens without sugar because we wanted to know if yeast metabolized sugar. So this would be our experimental group. We put the sugar in there. This is the one that we intended to use to answer that question. Is it metabolizing sugar? But of course, we have to have something to compare it to know if that was really the difference or not. So this would be our control group, and this would be our experimental group. To answer that question. Number 9 says, when you make bread, if you mix flour, sugar, and water, the dough does not rise, and the bread will be flat and hard. If you include yeast in the bread dough, the dough rises and the bread is bigger and fluffier. Can you explain how the yeast helps the bread dough to rise? Well, think about what we just saw here. Okay. Our yeast, if you can see in there, it's all bubbly. And there's gas coming off because the gas is in our balloon here. So if you've ever looked at good yeast bread, it has a lot of little holes in it. Well, that's the bubbles of carbon dioxide gas that the yeast is giving off. And that's what made the bread rise and makes it be light and fluffy. So put something like that in your answer about the carbon dioxide gas given off by the yeast with the sugar, and making the bubbles in the bread makes the bread rise and makes it light and fluffy. Number 10 says, you have opened a bakery selling bread made according to your family's secret recipe. Unfortunately, most customers find the bread too heavy. Review what you have learned about chemical reactions and make a list of factors, such as temperature, that might affect the enzyme catalyzed fermentation reaction involved in baking bread. Predict how each factor will affect the rate of fermentation And propose a solution for making the bread lighter by adding more bubbles to your family's bread recipes. So think about the factors that affect the enzymes. Think about our yeast. If you get the water too hot, then it's going to kill the yeast and they're not going to bubble. Maybe if you don't have enough sugar in there, the yeast didn't have enough to eat, or maybe you didn't let them eat and metabolize long enough. If you let it metabolize longer, they have time to release more bubbles. So as we went further into our observation, we got more gas released. So maybe you need to let the bread rise longer. So just think what you would think would work and put that there as your answer. And so finish up that lab report. Make sure you attach and submit it and turn it in. It will be graded, so make sure you do all that. Attach, submit, and turn it in. Complete everything. If you need to go back and look at it again to do your observations, you can do that. Now have a good day.